Today I'm going to look at this really killer oscilloscope. It's one of the first oscilloscopes made. It's the HP130BR Romeo. It is just a wonderful old piece of equipment. It actually works. A while back I replaced a bunch of the tubes in it that I thought were probably bad, and today I'm just kind of doing an initial calibration on it. So there's all sorts of directions online. I'll put the link to the directions on what I'm doing online and point out the pages if you want to follow along at home. Wow, what a good shot. Okay, so here's the front of the oscilloscope. We got a nice little scope trace going on there. I've let it warm up now for about a half an hour. And I've done the first couple of steps just so that I can have an idea what I'm actually doing here, at least on the first two steps. So it's real old, obviously. I don't know what era this is, maybe the 60s or maybe the late 50s. It's pretty ancient, and it's a lot of fun to think of maybe, where this was used. I'm in Colorado, so it was probably used for computers or something like that. That was going on here in Colorado quite a bit at the time. Maybe military. That's, there's a big military presence here in Colorado, down in Colorado Springs and in Denver. So perhaps it was used for one of those purposes. There's also schools. Maybe some of the schools around were using it. So, so let's just start. I've already done some of the setup for the first couple of them, so I'm not going to bore you with too much of those details. But the first thing you want to set up is your vertical deflection and do your DC balance. And so right here is the calibration signal. We're set to an internal sweep on the calibration signal. So see here on the calibration signal. So that's where we're actually getting all our information from, is that calibration signal. So what it says is to start to set up this bottom line at 0 and kind of set that up. So what I'm actually going to do, let's see, I wonder if I can do this, kind of set it in the middle. Well, that's not going to work very well. So I'm going to set it right here and set it to the center graticule, and then also it tells me to go to this 1 millivolt per division setting and then adjust this. And there's a coarse adjustment right here as well, but I don't really need the coarse adjustment here. And then go back and forth as many times as I want to see that it's kind of in the middle. So we're going back and forth. It takes a couple seconds to kind of settle out. I really haven't done anything to this. All these switches could probably use some of the can of cleaner sort of stuff to clean all the wipers and stuff. And one thing I've noticed is this just isn't snapping back the way I'd really like it to. I've also noticed a lot of ripple in the trace, and that's probably due, and it's more apparent here. It probably has to do with there's probably a cap that's going bad somewhere. So we'll track down that cap eventually, but right now I'm just trying to get a feel for the operation of this scope. These old scopes, they operate a little funny, so, and each one operates a little differently. So I'd say we got the DC balance pretty good here. Each time you switch it, this has to be adjusted just a teeny tiny bit. You see, now it's down a little lower. So I wonder if I can do this, then do this. That way this vertical position is more centered. And this is just anal retentiveness. A lot of engineers have this little retentiveness gene, I think. So if we kind of do this, kind of get it right in the right ballpark, and then kind of, yep, zoink. Okay. Now if we kind of bounce back and forth, no, that didn't help that at all. So see, what I was hoping was that this would actually not have to be here anymore. No, I'd really like this to be kind of lined up straight. See, it goes from here to here, but it doesn't line up perfectly straight. And so I was hoping by adjusting this differently, maybe it would, but that doesn't appear to be the case. So let's go ahead and bring this back down. Let's set it a little high. I know all right. Perfect. All right, so we'll go back and forth a couple times. Set this adjustment the best I can. All right, that's about good. Okay, let's move over to the other side. And then, so if I remember correctly, this has to be set to cal. So we have the cal input going to both the vertical and the horizontal. Now this should be a straight line. It's not. Here, let me turn up the intensity a little bit. Maybe you can see it. It's not quite a straight line. It's got a little bit of shift there. We'll get into that later. But the same sort of thing applies, is that you want this dot to be on the center graticule. You can see the vertical position's not quite right again already. But, you know, you can also do this. Maybe short out this again. Yeah, and that gives you a nice tight line there. So, you know, we've adjusted this to the center graticules again, and we put that beam right in the middle. I'm going to turn down the intensity. I actually burned out a CRT quite a while back by having too much intensity. So I'm a lot more sensitive to that these days. And then so the same thing, going between the cal and the 1 millivolt per division deflection to set that DC balance. So we'll put it there, and we'll jump over here, jump back. I'd say that's pretty good. Seems like the horizontal one is a little bit bigger than the vertical one. I'm not quite sure why, but it kind of seems to set. And you know what? These old scopes, they tend to drift quite a bit also. So you actually have to do this procedure quite a bit sometimes when you're doing this. So, okay, well, that's the first two steps. Let me look at what the next step is, and we'll keep moving. All right, so I've set up my function generator here with these little cables. And so I should be starting to see some stuff on the screen as I put it in here. I have my function generator set up to put about 1 kilohertz. I haven't calibrated or anything, but it's about 1 kilohertz at about 2 volts peak to peak. So let's see where we can get to with it. Let's see. So it says we've already set our sweep mode to preset. And then connect vertical input signal into vertical input signals. Okay, so we've done that. We've connected here. Set AC/DC switch to desired coupling. I want to do DC coupling, just vertical sensitivity for desired vertical sensitivity. So I set that to 2 volts per division. We still have the horizontal set up for the internal sweep triggering. then hit, let's see, I just did step 6, set vertical sensitivity for, yep. And so now we're doing step 7, set trigger slope switch for triggering on positive or negative slope. It doesn't really matter. Set trigger level control to 0. So where's the trigger level control? Okay, so we've set it to 0. Select desired sweep speed. Okay, so since we're at 1 kilohertz, let's set our sweep speed to 1 millisecond. And so that should give us, we should be getting 1 cycle per centimeter here. Adjust trigger level to start trace at desired level. Alright, so let's turn up the intensity, see if we have a trace. I'll be darned, we don't have a trace. What's going on? Well, let's bring down the vertical sensitivity a bit. Maybe adjust the vertical position. No, not seeing it. See if, oh. Well, that's setting it to free run. Oh, you know what? Well, there's free run. But we don't want it to free run. So we definitely get the signal into the input, but it's not triggering for some reason. Let's see if we can set that trigger properly. No, it's not doing it negative or positive. I am positive that this worked last time I did this. So sometime between last time I worked on this and this time, it no longer works. Let's see if AC coupling helps. Input, no. Let's see. We go back to free run, it's doing it. But it's not doing it. Not sure what to do next. I read some more of the manual and it says as long as you have more than like 1 centimeter of deflection, it should trigger. And for some reason it's not. And this is only a roughly 1 kilohertz signal. And this scope has about 300 kilohertz bandwidth, so it should be well within the operating range for this particular circuit. So, just kind of going through the steps a little bit. Horizontal sense to internal sweep X1, so that's there. Obviously the vernier should be in calibration for everything here. Sweep time to 1 millisecond per division, we got that. Sweep mode to preset, and then it says set sync to external with no input. So I don't quite know what that means, but we'll go ahead and set it on external with no input. Connect VTM to 30 volt range between center arm of preset, R220 and ground. Okay, so this is where I'm going to look real quick. The scope's been warming up for a little while, so hopefully there won't be too much high volt. Yeah, there's always high voltage, especially in these old machines like this, because the cathode ray tube, this guy right here, can have several thousand volts on it. So it's real important. One, if you're doing this and you don't know what the hell you're doing, don't do it. And then two, even if you know what the hell you're doing, be super cautious, because this can cause you to have a very, very bad day in a very, very big hurry. So I'm being very cautious here, using one hand behind my back. I'm actually getting minus 0.6. Oh, I'm in the ohms range. So put it in the right range. And I'm actually getting 0 volts on R220. Oh, no, there it goes. Minus 24.3 volts. Judging from what it says here, the next step, slowly adjust R20 and note voltage just prior to sweep start. Just preset for 2 volts more positive than the voltage noted. Okay, so 2 volts more positive. Okay, so I think I will probably turn it off here real quick. So let's turn it off, just so it's somewhat safe. I know there's can still be some capacitors that are charged. I mean, this shit can kill you. I mean, no joke, okay? If you don't know what you're doing, don't do it, please. I've got 10 years of experience in electronics, high voltage, low voltage, well, I shouldn't say high speed, but relatively decent speeds. And I'm still scared shitless over this stuff. I've gotten across 277, and that was not fun. Thankfully, it just got over my finger and not across my body. Sure scared the Jesus out of me. But anyway, so be extremely cautious doing this sort of thing. In fact, I'm not sure I have all the tools that I really want to really make this safe myself. So I am still being super duper cautious. Let's see, let's turn it back on. I'm seeing that voltage charge up. Now it's going negative. I don't know if this is the right voltage it's supposed to have on it, on that center tap or not. I'm kind of hoping and wishing for the best. So it's currently at minus 24.3 volts, 24.2. And I'm going to say that it's probably pretty close to warm enough to make this adjustment. I'm just going to make this adjustment, see if we can get that sweep to go. Let's see. No dice. I've rotated it the full gamut of let's see if we can set it to internal, get it to trigger. So be very careful. The hand just slipped just a little bit. Oh, sorry, I'm getting in the way. No dice. I just moved that all the way around again. Didn't see a single trigger. Well, that's too bad. Okay, so I looked at the schematic a bit. And really, there's 3 things that I think could be wrong. And one is that the vacuum tube's not working, or the voltages are out of spec. I haven't looked at the voltages on this quite yet. I don't really care what they are. Although that might help a little bit. What I had the top apart, and I couldn't tell for sure if this tube was glowing or not. And so I think that might be the source of our problem. I It's a 12AX7 tube, and thankfully those are pretty common. So I will probably, I think I have one somewhere that I know where it might be at. So hopefully, if we can see this guy, I haven't turned it back on. Let's turn it back on. It might take another minute to warm up or something too. If we don't see this guy glowing, it's very possible that it's this vacuum tube. It's hard sometimes to tell if they're glowing or not though also. So you got to be careful in that regard as well. I actually think it is glowing. Let's turn off the light. Take a closer look. And so the one we're looking at is right here. And you know, with all the glass and stuff, it's hard to tell, but I do think it's glowing, and I do think it's probably working. I don't know that for sure, but my guess is that it's probably working at least somewhat. So on to the next thing. But one thing I want to show you though is how cool this little door is. I don't want to mess it up too much, but see this door? I mean, I've worked with Tektronix equipment and stuff. I'll tell you, that Tektronix 547 over there does not have any doors like this. That door is super duper handy. So anyway, let's maybe check the voltage on some of the pins on this thing. Let me turn it off and close the door, and then we'll check some voltages. Well, I figured out the problem. So here we are in kind of a free run mode, just barely getting to where it starts triggering. And I can go all the way over. But if I turn this, watch. I was only going to there. Listen. Now it's in preset mode. So it's working just fine. I'm an idiot. That's really what it boils down to. Oh well, though. I mean, that's part of learning these things, is learning how they work. And so I messed it up that time, but that's alright. Now I can choose where in the signal line to actually trigger on. It's actually working beautifully. Holy cow. So note to self, this is actually a clicking switch. I was looking at the schematic and it kept saying switch 203, I think it was. And I'm like, what is this switch there? And I couldn't figure out what it was. Well, I'm pretty sure this is a switch. And it has this, it's part vernier, but part click in for the other vernier, which is the resistor 220, I think. So anyway, long story short, I got it working, which is always pretty fun and pretty good to see that it's working. Honestly, I've made no adjustments to this point other than just your basic, horizontal DC balance and stuff like that. So, which is pretty remarkable. But I'm tired. It's about 10 o'clock. I'm sick of looking at this thing for one day. So I will work on it some more in the morning. See ya. Peace. Good morning. I'm just going to jump right into it. I finished up that test last night, and I thought of some more tests that I'd like to show you today. Kind of getting off the instructions, but this is a great test. You can see that I've got 10 divisions of deflection there, and it's basically peak to peak. Now this particular scope is spec to be at about 300 kilohertz bandwidth, and I will show you that it's actually a little better than that. So let's set up this trigger a little more nicely. There we go. So we've got 10 units of deflection. So in order to find out the bandwidth, we want 7.5 units, or 7 units of deflection. So we have to go down 1.5 on both sides. 1.5 on both sides. You add that up, that's 3%. So, you know, it's about 70% is what the 3 dB bandwidth is. So I've also got my counter hooked up, and right now it's reading 151 kilohertz, which is really pretty good. So it's getting that full deflection. I've also made the frequency lower, so if I make it a lot lower here and change the time base, you'll also see that maybe it's gone down a little bit. And so let's start here. So we're at 14 kilohertz now. So let's readjust here just a little bit. We need to adjust the vernier so that it's peak to peak. They actually call this single-ended millivolts per centimeter instead of division. And right now I'm in volts per centimeter. It's actually volts per division, but so basically I have about 1 volt in there now. I haven't calibrated it quite yet to know exactly how much deflection I have on my output voltage of my function generator, but I know from experience that we're somewhere around 0.1, about 1 volt deflection, which is about what I want it to be. So let's see what else. All right, so now we'll up the frequency, and I actually got to put it in the next higher level, which will make it about 150 kilohertz. Again, we'll zoom into it a little bit. You can see that the amplitude's gone down just a little bit. Oh, we're wanting to zoom into it, not out of it. It's gone down just a hair, but we're going to continue to kind of ramp it up until we see about 7 centimeters of deflection. And so that is about 7 centimeters of deflection, and my counter is telling me it's got somewhere in the range of 540 kilohertz as its 3 dB bandwidth. So that is excellent. All right, for those playing along at home, I'm on page 15 doing the external synchronization. So basically the instructions for this one are exactly the same. You put in a signal in here, and then set your sync to external, which I've already done. I just did it to make sure it worked. The sweep mode's in preset. Yep. Okay. Silly drone. All right. Now feed the signal into here, at least 0.5 volt sync peak to peak. Into the horizontal input. Now I have a synchronizing signal, but I don't have another coax to BNC connector or anything like that. So I'm going to have to just kind of put this, connect these two together. Focus, focus, can you focus, focus? No, it's not going to focus. So I'm just going to put these together when it comes time. Set the AC-DC switch for type of coupling desired. We'll keep it on DC for now. Set trigger level to 0. Okay, well, that's close to 0. And feed vertical input with the same signal, which I'm doing. Select, okay, so, and then set your sweep speed so it displays, and set your vertical sensitivity so that it works, and then the slope that you want. So it's working all pretty much the same. So we're just using a synchronizing signal to be able to view the trace, and there it is. I mean, that's a synchronizing signal, and this thing still works, guys. I mean, this is maybe 50, 60 years after the fact, maybe even 70, who knows. I haven't really looked too hard for a date on this, but look at that, it's still working. The internal sync, the line sync, the external sync, they all work. You can trigger free run. The sweep times are working. The horizontal, the vertical is working. I mean, every knob on this guy is working. The CRT's working. I mean, it's amazing. I mean, they really built these things to last, and it's literally 60 years down the road. It's incredible. Okay, back to the external horizontal input. We'll go ahead and do that one next. I'll just keep the camera rolling. Feed the horizontal signal to the horizontal input terminals. So let's disconnect these things. And we will feed our syncing signal, our signal into the external inputs this time instead. So connect this here, connect this here, pull these out of the way, in the way. Let's see if we can get you a little better shot too. That's good, probably. Yeah, somewhere in there. Yeah, that works pretty well. So get some cables out of the way. You got to be real careful. I still have the case detached, so you don't want any cables going and hitting the board and shorting something out. So set the horizontal sensitivity to the desired sensitivity level. We'll set it to 0.01 just because that's what we had before. Oh, wow, it's jumping back and forth between a couple levels. See there? Huh. Is that just a horizontal position thing? I don't think so. Oh, you know what? Yeah, it's going to jump back and forth each time you change this, right? So there it's half, a little bit less, a little bit less. Well, that shouldn't have been more. Oh, see there? There's a little bit less, a little bit less, a little bit less. We got a dot now. This might just be dust on the wafers. I think it's dust on the wafers. So I'll blow it out with the blowing stuff real good. And so it's working reasonably well. So we should have about, it's obviously out of cal. Either one of these two are out of cal. So we'll do cal here once we make sure all the general operations working. And so far, it's working great. And there's another thing to look at while we got it here. And just make sure it does a residual pattern. We'll set this to that and that. All right. Oh yeah, it might be pretty well in cal because remember I had this one in vernier to kind of get it to the peak-to-peak deflection there. So let's do the horizontal position, kind of line it up. Look at how nice that is. And what we can do now is connect the grounds together and connect the deflection together, and we should see a straight line, but look at that, we don't. And we saw that earlier as well, but you know what, we can calibrate that and get it in good form. So I'm not worried about this at all. I mean, it's still 50 years later, still operating pretty well, I'd say. So there you go. Look at that. Perfect little ellipse. Love it. It's always fun to play with these things a little bit. Alright, AC coupling, balanced inputs. Well, you know what? I need to grab a part for this, so I'm going to shut it down for a bit and go work on that. And then the step after that is external CRT deflection. I'm not going to work on that. It would be very rare that somebody would need to do external CRT deflections for something like this, especially somebody doing audio type work. Maybe you might want the Z deflection, and if that's a problem for somebody using audio that wants to buy it from me. Maybe I'll make some changes there, but right now I'm not going to do anything with that. It's just not very useful at this point. But let's go ahead and go do the AC coupling and the balanced input. That's going to be pretty important. Okay, so I have set up for the next little test, and it is for vertical deflection balance, AC balance. So I've put the little capacitor here, grounded this guy, and so the whole idea is I'm putting in this signal, and when I go to ground this point to this point, there should be no change in the signal at all. I've set this to internal. It doesn't talk about some of these things in the instructions, but I've set it to internal trigger, so it'll continue internally triggering. And so when I connect these two together, there should be no deflection. So it is, it shouldn't change at all, and it doesn't. So let's go ahead and do that really quick on the other side as well. Let's see, I'm gonna have to have something to kind of, I don't know the last time these things are pulled off or apart. There we go. Maybe that's enough to kind of isolate it there a little bit. Yeah, I think so. I don't have any room below it. Would have been nice if they had these up just a little bit further, but yeah, whatever. It still works, so I'm not complaining too much. Let's pull this off. Well, should see the trace disappear because now it's no longer triggering. We can connect this here, and then connect this here. And we might have to put a synchronization pulse in here to get this to work. One thing you'll find in these old instructions is that, they kind of expect you to kind of have an idea how these things work. So, but again, let's see. You know what? We could probably just line trigger and slow down the sweep speed. There we go. There we go. That's a nice little trigger. We have nothing going into the inputs. We could short them out. Here, let's short them out just real quick, just so we know for a fact there's nothing going in there. We got, and then let's start changing this a little bit. Oh yeah, see? Getting a nice solid line there. Maybe it's out of focus a little bit. It's in focus. It's a lot thicker than I'd like. See? There's something going on there. Not sure exactly what yet, but there's a little something going on there. So the basic idea though is that these ends should stay the same when we short out when we ground the return of the function generator. So let's go ahead and do that. See if it moves at all. No, didn't move at all. So we need to be in AC coupling mode. Yeah, see, nothing happened. It's working great. Well, you know what? It might be hitting that a little bit. Oh, really? It's sensitive to me just tapping it. That doesn't seem right. I don't know what's going on. But it's for sure not moving when I connect that in. Oh, you know what? Some of the fuzziness there might be due to a bad connection here somewhere. So maybe I'll make it a little bit better. Can you believe that? That thing is super old. I just went through all the basic functionality. It all works. The entire thing works. Now, about a year, maybe 3 or 4 years ago, I got this thing and I started changing some of the changing the tubes in it because it wasn't working at the time. So I had to replace probably on the order of 6 or 7 tubes, something like that. And at this point, you know what, there are a lot of vacuum tubes in there. I think there's 22 tubes, something like that, and they're all working, every last one of them. The CRT's working, the boards are working. You know, it needs calibrated. That's all it needs. It just needs calibrated. So we will go ahead and do that here shortly, not too long. We'll do with the best I can with the equipment that I have. I don't have outstanding equipment. I certainly don't have frequency references and stuff like that. But I got a frequency generator, a very accurate counter. I've tested it several different ways and it's very, very accurate. So that will help a lot to get the frequency correct. And we'll maybe do some rise time, fall time measurements and that sort of thing. Maybe, I don't know. But it works! I'm going to look more carefully for a date on this thing and see if I can find out what the date is. But the damn thing works. It's freaking-incredible. The guys at HP, literally, if you're still around, high five. You guys nailed it on this thing. I'd really love to talk to one of the designers that designed this thing and tell them how impressed I am with it. But anyway, from the bottom of my heart, it's incredible. I know this is one of the first oscilloscopes put out, at least on a commercial level, and it works. I mean, still to this very day, 2017, August of 2017, it blows my mind. Anyway, I hope you enjoyed this video. We'll do another video where we're doing some calibration on it because I actually do want to get it out of here. I got to free up some space in my room and work on some other projects, but I really want to get this into the hands of somebody that'll use it and use it willingly and know what it is, understand what it is, and enjoy it. So anyway, peace out, 5000G. I love this thing. Later. Hey, you've been able to see me this entire time.